This is a recording of a presentation given at a local Nkosi, Delaware Valley chapter meeting. The topic was Systems Engineering and Agile. The presentation was actually part of a student organization at University of Pennsylvania that's associated with Nkosi, and that student organization is jointly linked with the local Delaware Valley chapter. And so they were interested in some of our background, and both myself and the other speaker, we talked at length about our backgrounds, and then we went into our topic of discussion. My topic of discussion, again, had to do with Agile and systems engineering, and I started out with an audience query. Basically, the question that was tossed out to the audience was, who in industry is using Agile? And essentially 100% of the industry folks raised their hands. They're all using Agile in some form. I then asked the same question of the students. Are you aware of Agile? Have you had course material of Agile? Anything having to do with the term Agile or whatever? And none of the hands went up. At that point, I then started to move into the presentation. Agile Key Elements. Okay, Agile is actually a big space, and just like the other kinds of processes and approaches that surfaced in years past, it tends to grow and have a life of its own, and the initial concept attracts many different things to it. And what I want to do here is just touch on these particular key elements over here. I want to talk about the Agile Manifesto, the Sprint, the Scrum, the Demo, the idea of extreme programming, pair programming, and a planning tool. And the example is JIRA. The Agile Manifesto. This is what it is. You can go out there on the internet, you can Google it, you can find it. Basically, you'll find this statement up there. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. And then the Agile Manifesto was signed by these folks over here, and basically the copyright notice shows 2001 as the time frame. And one of the more serious contributors, significant contributors there, is Steve Millar. So let's step back a little bit. Let's discuss a little bit about Agile software development history. Agile is a software development methods. It's a collection of methods where requirements and solutions evolve through collaboration of self-organizing functional teams. This is how the community views themselves from one perspective. The Agile Manifesto was made in 2001. Agile methodology, some people are able to trace to the late 80s and early 90s. And the sources are work at DuPont, James Martin and James Kerr, and again, the manifesto came out of a consortium, the DSDM consortium, in 1991. Agile software development history. It turns out that in 1970, Dr. Winston Royce wrote a really important paper. It's called Managing the Development of Large Software Systems. In that paper, he essentially criticized sequential development, where you gather all the project requirements, complete all of its architecture and design, and then write all of the code. He realized that iteration is needed and that there's learning that happens between the phases, and essentially what you have is you have a loop that occurs between analysis and coding. And he also realized, and so did in fact, many people realized this. He just took the time to write this down. Okay, not to take away from his very important work. This is really brilliant work in that paper. There's a communication breakdown between each phase. That used to be called the brick wall. And a really good example of the brick wall was between systems engineering and software engineering. Systems folks would put things together, they'd throw it over the wall to the software folks, and they would then proceed to ignore it. But there were brick walls all along the process chain is the best way to describe it. You had software designers that throw things over to the software coders who would then proceed to ignore it. The software coders would throw their stuff over to test, and requirements and everything, the resulting design, nothing would come together. In any case, there would be a communication breakdown between each phase. Continuing on with Dr. Winston Royce's work, this paper is a lot more sophisticated than Agile, and it really is worth a read. And at this point, what I want to do is I want to point to something very important. It's the concept of hidden agendas that are pushed, especially today. And I mention this in all my course material, and I'm going to mention it here again. Professor Harry Frankfurt from Princeton University, he's a philosopher, and he basically came to the conclusion, like many other folks, that there's something wrong with our institutions. And he tried to come up with his own theory of what may be happening, what may be going on. And what he detected is that essentially people are pushing agendas out there, and when they do that, they engage in two ways. The first is they either lie or they engage in what's called bullshit. And this is an extremely important concept because liars know that they are lying. They're pushing an agenda, they're lying, they know that they're lying, and they're redeemable. Okay? They not easily, they could be taken to the point of just sort of crying and saying, yes, I'm lying, this is all wrong, there's a hidden agenda here. The bullshit artist doesn't care. They don't care whether they're lying, telling the truth. They don't care whether the agenda is valid, not valid. They're just pushing the agenda. And the problem with the bullshit artist is they're not redeemable. And from that point of view, because they're not redeemable, we have a serious issue. Okay, so that is essentially the thesis, and it's very, very important because this tends to oversee and overshadow a lot of things having to do with the software space, the system space, the management space, high technology, the way it's unfolding in our society, etc. So I just want you to have that in your background, in your thought process as we go through all of these issues related to process and quality. So Agile was born in a certain kind of environment, and essentially Agile was for small projects. It was for 7 people, plus or minus 2 people, and again the projects were small, and an issue was surfaced, and that is, wait a minute, most of our projects are very large. How can we scale this? What can we do? And Dean Leffingwell came up with the Scaled Agile framework. And essentially, this is the answer to Agile, okay? And it was sold to large companies for very large software projects. This is what Scaled Agile framework looks like. You can go out on the internet over there and you can study it. You can buy books, etc., etc., etc. So, Agile Key Elements. We just went through the Manifesto, okay, the original concept of Agile. We went through where it may have come from and what people were, dealing with in terms of, the approaches to software development as early as the 70s. And what we see is that we have processing and tools that tend to aggregate. They tend to snowball, and they tend to take on a life of their own. And so Agile has now become Scaled Agile. And different pieces of history are being accessed and attached to the Agile community. Different tools are forming up and being attached to the Agile community. Okay, so I'm going to talk about these other items over here: Sprint, Scrum, Demo, Extreme Programming, and Planning Tool. And again, there are many Agile elements, but that is our focus right now. So here's the big picture view of Agile, traditional Agile. What you have is you have the start of a project, you have the end of a project, and essentially what you have is you have iterations which are called sprints. And during a sprint, you essentially go through the entire life cycle of development, for lack of a better word. You have what might be called detailed requirements, design analysis, implementation, developer testing, QA acceptance testing, and then deployment, but it happens in a 2-week window. Okay? All of this stuff is done in 2 weeks, each iteration. This is as opposed to the waterfall model, and this is the agile perspective of waterfall. And essentially this is the limitation of the waterfall according to the agile community. So Sprint is supposed to do this for some portion of the system. Obviously you can't do this for the entire system, you're doing it for some portion of the system. A sprint, essentially it starts, you create a plan based on stories that have tasks. That's essentially how a sprint gets born. The staff swarms to the stories and the tasks, and a demo is developed after 2 weeks, and then that ends. And then you repeat. You go, start with new stories and tasks. A scrum, that is a daily meeting where essentially only 3 questions are permitted. What did you accomplish yesterday? What will you do today? And are there any blocks to you working the story? And it's reported in very narrow window time frame, 2 minutes per team member, for example. And then you have an agile demo. Now this is really important. When people think about agile and demo, they're not really familiar with these things. They think in terms of dictionary definitions of agile. They think in terms of dictionary definitions of demo. That has nothing to do with it. Okay? This is something that folks have developed conceptually and are using in particular areas. So this is not a dictionary definition or even a government definition of a demo. The US government has a definition of what a demo is. An agile demo is a completed software item that is shown to the customer. It is done. And if it's accepted, it's never touched again. That's important. This is the final version. It's never touched again. There is no concept of making the software production ready or of deleting debug code or throwing away code. Okay? The demo is it. You're done. Begin the next sprint. Okay, extreme pair programming. Essentially 2 programmers work on the exact same code in parallel on the same workstation. Now actually when I first started working, everybody was always paired up. There were always 2 people working the exact same problem, and typically it would be someone who was senior working with a younger member of the staff, and that was a way of basically bringing the next generation up. That went away. Okay, it started to happen in the 80s. In this particular case, it's easy for me to relate to this model. Other people might have difficulty relating to it. In this case also, there are some stipulations. It's more intense than perhaps what I witnessed when I first started working. In this particular case, what we have is we have one person who is the driver, they're writing the code. The other is the observer and is the pointer or navigator. And they both review each line of code as it is typed. Okay. In the past, what would happen is you'd have 2 people working the same thing. If it was code, they'd be working the code. But what would happen is the other person would review what the other one did in an offline, in a separate setting, and then they'd get together. And then they'd switch off. Okay, and all of a sudden the other person would start to code while the original person who coded the first set would take on the reviewer role. Okay, but they wouldn't be sitting next to each other per se all the time. Again, the programmers switch roles in extreme programming. One is coding and one is watching, then one is watching and one is coding. There's a planning tool out there. It's called JIRA. It's internet-based, and it essentially encodes the Agile process. And again, the Agile process, it's taken on a life of its own. And what we have is we have epics, features, versions, releases. We have burn down reports and all kinds of things. But the focus here in my discussion was stories and tasks. And the interesting part is the visibility is just like the internet. It's very, very fine. If you have a website, if you have the pleasure of maintaining a website, you can maintain logs, and what you'll see is you'll see visitors arriving every 10 seconds, every 20 seconds, and you can essentially move that into some mining software, and you can detect certain patterns and make certain conclusions. Well, it's very similar here with this JIRA tool coupled together with this agile process and what it dictates. The visibility, like the internet, is very fine. Tasks are in the 2 to 16 hour increments, and so what you have is you have massive tracking that's made available. So here's an example of agile stories and tasks in a sprint. And I'm just going to read off some of these things. Research options to travel to Pluto. That 5 over there is 5 hours. Now, I don't know if you can essentially research options to travel to Pluto in 5 hours, but I suspect in a real industrial setting where you have to do the work, this might be a 2-month activity, a 6-month activity, maybe a 2-year activity, and maybe the team is anywhere from 5 to 100 people. That's me, however. Requesting available flights is now taking greater than 5 seconds. That's a JIRA task inside a story over there. What you see here, again, is tasking that's very, very fine down to the 5-hour level, the 6-hour level, the 2-hour level. And it doesn't matter if, for example, the tasking may not fit those hours. I'll repeat that. It doesn't matter if the tasking doesn't fit those hours. What happens is people tend to get, how can I say, they get lost and they become unrealistic. So the first task of research options to travel to Pluto is obviously an unrealistic task. Okay, we'll talk about aerospace companies. This is an observation. So let's just move in. Here's 2 pictures over here, different times and different places. If you take a look on the left, that's Hughes Aircraft 1962. You take a look on the right, that's Raytheon 2015. On the left-hand side in 1962, President Kennedy basically went out to industry and said, we can't handle all of this high technology stuff you guys are giving us. You're giving us all of this paperwork that we need to consume, and we can't read it, we can't understand it. Can you please figure out how to present this extremely complicated high technology stuff so that we can make intelligent policy? And what Hughes did is they went off and they created this thing called sequential thematic organization of publications. And I'll talk about it more later. But that's essentially what you see on the left-hand side. And again, we'll talk about it later. So they invented, again, I guess I'm talking about it now, this thing called sequential thematic organization of proposals, and it was born in an engineering and science environment. It used those approaches, those thinking approaches, that culture. And what you see here is a storyboard wall review room. You see information products on the wall, and you see people interacting. And this is Hughes Engineering 1962. So what would today's wall rooms look like? Would they look like this? This is, again, 1962. So now I want to talk a little bit about Hughes Engineering. They had daily team meetings also. They lasted about an hour. Everyone essentially presents their technical content, if any. Maybe you don't have anything to present, which is fine. There's engineering questions and dialogue that happens as the team desires, whatever essentially they think is important to talk about. And then there's requests for management to facilitate if needed. For example, I may be interacting with some folks and we decide that we need to go travel and visit a particular facility. Maybe we need to go visit a particular company to go examine a piece of technology. And we turn to management and we say, we need to make travel arrangements and we think the following folks need to go. And they go and they facilitate that. There are presentations that were done every 2 weeks. The presentations were done typically in a 4-hour block, such as the morning. At those presentations, everyone would get together and present their research findings, recommendations, issues, requirements, functions, analysis, models, etc. And there would be questions and dialogue that would happen as the team desired. Now, if some folks didn't have presentations, that was fine. What they would do, however, is they would question other folks that had presentations. And in that dialogue, again, the knowledge base would start to grow. The problem-solving issues would start to kick in. The problem-solving mechanism would start to kick in. So continuing on at Hughes Engineering, it was all about engineering and science. This was acknowledged as a learning organization with massive information sharing and collaboration. There were never any statements of, we don't have time or money. And no time was wasted claiming that you worked. For example, if people just talked about that they worked rather than engineering content, they were gently encouraged to change their thinking to move into this very different high technology world. Okay, we're talking about stuff having to do with engineering and science, not that I worked. And Hughes never gave up on them. It turns out that these kinds of folks would just sort of leave. They had a difficult time in that kind of setting. So let's take a look at this storyboarding session at Hughes Fullerton. Let's look at the body language. Let's look at the facility. If we take a look at the group of 3 individuals in the center, we see that someone is enthusiastically explaining something. The person to the left is listening to them and maybe in dialogue. The person in the background is listening to the two of them dialogue, and maybe he's not sure what they're saying, but they're engaged in some kind of heated debate discussion. Then you see a third person sort of stepped back away from the wall, trying to take in the big picture. Okay. And let's look at the facility. This is 1962. It's a rather large room, well lit, relatively clean. In terms of hanging paper on the wall, it's kind of functional. Now let's take a look at Agile in 2015. What we have is we have our Scrum. It's daily. It's about 15 minutes. And only 3 questions are permitted. What did you do for me yesterday? What will you do for me today? What are your blockers? We don't want to know about blockers in many instances. The sprint planning is 2 weeks. It takes from 4 to 8 hours to plan a sprint. And the reason it takes so long is because there's inch-stone tasking, which is essentially 2 to 12 hours. And there are sprint retrospectives that are held. They tend to be 1 to 2 hours, and there's likes, dislikes, and they're either incorporated for the next sprint or they're not. Okay, so let's move forward to 2015 Raytheon. It turns out that Raytheon bought Hughes Aircraft from General Motors. And what we see here are Raytheon engineers using agile techniques to collaborate on a variety of complex systems. That's essentially what the caption says on this picture as part of one of Raytheon's website content industry release stories. And in the background, what we see is we see a person, I hate to tell you, but I think his thoughts are, I don't know why I can't retire. I wish I could have retired. I can't believe I'm here. What am I going to do? Then we see a person to the left who's wearing the cap, and he's just thinking to himself, I got to get another job. I need to get out of here. And then I'm in the blue shirt, essentially, looking at this, trying to figure out how all of this stuff is going to unfold, because it's really rather interesting. Anyway, that's one way to potentially interpret this picture. And this is Raytheon 2015. Take a look at the contrast over here. What we have is we have engineers and partners collaborating in a cave on a video conference. Everyone explores 3D models together. And rather than you have one group presenting to another group, they're interacting inside this cave. So again, the engineers and customers are collaborating. This is beyond the education smart boards that exists at places like Drexel University. And the question that I have here, is this current technology? Continuing on, a high technology organization, potentially today, I kind of removed the Raytheon off of it, but essentially, that's what you could stamp it. Do you really think they are asking, what did you do for me yesterday? What will you do for me today? What are your blockers? Now here's the issue. Few understand the high technology civilization that surfaced in the past 60 years, and this is a really big issue. Okay, so now I'm going to provide a view from systems and traditional management. The details after this section, essentially. So from a systems point of view, systems is strategic and long-term. It's big picture and inclusive. There's documented evidence. There's no room for selective memory. And it's based on traditional science and engineering, and selective facts to make a case essentially are not permitted. These are key system elements. Let's take a look at traditional management view. Micromanagement, crisis management, essentially if you take a look at Agile, many people will claim that's what it is, and the evidence that they offer is the inch-stone tasking. Okay, it's there, you can't deny it. While all of the planning is going on, what you have is lost opportunity cost. Again, very important management thing. Valuable time is spent planning and reporting essentially inch-stone tasks. Young engineers can't learn their industry because of the intense focus on 2 to 4 week sprints. That's all they're doing. And the other management perspective is that it's irresponsible and a very poor form of monitoring and control. Because monitoring and control is supposed to be passive in the background. The best managers out there are the ones where people don't know that those folks are even managing, that they are managers. It's just happening in the background. In this particular case, the monitoring control takes time away from work, and the work is actually engineering and science. That's what software development is about. And punching the clock tends to demotivate or stress the staff, and that's essentially what's happening as you identify 2-hour tasks that you then need to slide and drag in some kind of tool. So there's this master-slave architecture concept that has actually resulted, while at the same time the whole thing is being billed as being very egalitarian and the team deciding what they will do. The end result is actually a master-slave architecture concept where everyone is a slave to that tool, which in this particular case is implemented by JIRA. I keep calling it JIRA, and essentially satisfying those inch-stone tasks. Now, Agile can work. It can work when everything is known. You essentially just punch out the code and you get customer feedback. And obviously this is for trivial code applications where 2 or 4 weeks is sufficient time. Some babies take 9 months to be born. Human babies take 9 months. Elephants take over a year. Mosquito babies can be born much faster. Now there's the temptation to equate this with R&D, but it's not. Okay, the Agile folks are very adamant about this, that this is the final code, and we should respect that. And it really does make sense in certain settings. So this is not really equated to R&D, and that's because the code is not final. Everyone acknowledges that in an R&D setting, the code is not final. You need to go in there. You'll have to make it production ready. Okay, design view. And this is just a very small snapshot of design and Agile. I want to start with this idea of the Socratic Discourse and contrast 2 kinds of environments. Essentially, the Socratic Discourse is where you're trying to address a problem, trying to understand something by asking questions. And as questions are asked, other questions may be asked in response to those questions, or answers may be provided. And on the left-hand side, you have a Socratic Discourse in a teacher-student setting. Essentially, you have one person up there asking the questions, and then the students are providing the answers. For lack of a better word, you can call that a centralized architecture kind of concept. On the right-hand side, you have your Socratic Discourse in a peer-to-peer setting. The questions can come from anybody, the answers can come from anybody. Now here's the thing about the Socratic Discourse. It's not about the answers, it's about the questions. which questions are the most important. Because once the questions surface, the reality is most of the time the answers start to become self-evident. The trick is to get to the right question. So there's, two questions on the table here. The first question is, what did you do for me yesterday, today, and do you have any blockers? And I'll just flat out state that that is a non-technical management-centric approach to a particular kind of organization. And the other question that can be asked is, what are the technical findings, thoughts, and recommendations? This is engineering-centric. It is also technical management-centric. This is why in the early days when the high technology work was surfacing in those few companies that existed out there, they knew the difference between traditional management and technical management. And that's one of the things that hasn't permeated our society. We're working in this high technology space, but we have traditional management philosophies out there. They're non-technical and are trying to oversee extremely complex technical kinds of activities. The kinds of things that now exist in our high technology civilization. So the Socratic Discourse, if we take a look at it, essentially, again, this is a distributed architecture. It addresses a single problem using multiple minds. There isn't that brilliant mind saying, I've got the answer. It requires multiple minds. And that's because the problems are beyond the capability of a single mind, no matter how arrogant that person might think they are. And this is what's required in the high technology civilization. You have to have this kind of interaction and discourse that's happening. I'm going to shift gears a little bit, and I'm going to talk about model verification and validation. And this is a picture that exists, again, as part of our courses and a text that I have. And the idea is to address what's happening in terms of modeling and verification and validation. And at the highest level, what we have, this is a loop, but at the highest level, we need to find a starting point. So our starting point is a mental model. A mental model is just that. It's an idea that a stakeholder has in their head. It's a view of what they think this thing is. And what we have is we have scenarios. Those scenarios get somehow abstracted and written down, and they get pushed into a model. Many people think of a model as a single point thing, like a computer model. We'll talk about that in a minute, however. And then there's model outputs, and those model outputs are compared against the original mental model. So let's take a look at this diagram over here. Basically, let's just start with the domain expert, the subject matter expert. They have a mental model. They interact with a model specialist who also has a mental model, and that stuff gets input into this thing called the model. And what you have is you have the model results pop out, and the systems analysts, they have mental models also. And these mental models come out, and there's final recommendations that are sent to a decision authority. They also have mental models, and that translates into the system. And the domain expert now examines this instantiation of the system, and maybe this instantiation of the system is just paper-oriented still, or maybe it is a prototype, or maybe it's actually, the first releases of the system. The domain expert, again, looks at this thing, and the mental model is developed based on what they're seeing. And what you have is you have all of these different mental models, and they're in an audience. And they're sitting there at a review, and they're looking at all of this stuff, and they're all providing their own views of their own mental models and comparing them against the model outputs. That's what this picture is about. Okay. Given that, just put it out to the side, we can have two different design approach alternatives. 1 and 2, they're labeled over here. We basically have people on the left-hand side, they have mental models. Those mental models can be addressed and converted into a system model of some type that's captured via research, documents, computer models, production prototypes, pre-production prototypes, research and development prototypes, whatever. And then that system model gets converted to production. Okay? And down below, what we have is we have people with mental models, and they immediately go to production. And the way they go to production in software is they just start to code. And the production thing is made available and somebody looks at it. Now let's take a look at that system model up there. Remember I mentioned that many people view a model like a simple computer program that's implemented in Fortran or maybe MATLAB or something like that. A system model is actually all of the knowledge, all of the information products associated with the system. It is in the memics. That's why I keep referring to the memics, and that's why that work from 1945 is so very, very important. So essentially the memics is our internet today. In theory, all of our information products can be housed in an internet web portal for each project, and that essentially forms our system model from which we go and we produce. So here we have two different design approaches, and arbitrarily there are different dollar signs associated with each of these activities. So let's take a look at design approach number one, which I'll just call engineering. We have the picture up there, but then at the bottom I added some interesting things. On the left hand side, when we're working in the mental model space, the reality is it's not repeatable. And that's because people have selective memory. If you ask me what my mental model was yesterday or the day before or 2 weeks prior to addressing a particular kind of situation, it would always be different, and it will always be different the next day. That's what happens. We are human. Okay, it's not repeatable. It's called selective memory. What happens when we actually develop the system model and it's put in the memics? It becomes repeatable, and there's documented evidence. It's repeatable because you can go and read it. You can find it. The evidence is, again, it's documented evidence. Now, when you have your production unit that pops out, the thing, the solution, the system, what's going to happen at the highest level is the beast is either going to work, it's not going to work, or it's going to result in a major disaster. Obviously, if it's working, the quality is higher than when it's not working, and if it's a major disaster, obviously the quality is extremely poor. Okay, let's take a look at design approach number two, which I will just call Agile. We have our mental models. Again, they're not repeatable, they're selective memory. We're humans. And the end result is we're going to have production, and just like in the previous case, the beast is going to work, not work, or result in a major disaster. And we can equate these with quality levels. Now let's take a look at a design approach in the small business. I wanted to bring this up on purpose because we tend to have these two extremes. But there's this whole area called small to medium-sized businesses. They actually tend to work in a slightly different space. But what you might consider over here is that in a small business, they have to essentially maybe develop some software. They don't have the resources to buy hardware. Develop hardware, but they can buy hardware, etc. The whole thing starts with a mental model, and rather than an entire team, it's one person, for example. Up at the top with software, they might do some research, they might do some prototypes, and that captures the system model. Okay, the prototypes capture the system model, and then they decide whether they're going to go with a production, build, or a buy. Okay, and maybe there's iteration that happens there. And what's happening with the hardware? Again, they really don't have the resources to develop hardware. They may have the resources to develop the software. Again, it's a single person. What do? Well, they go off and they do research, just like above. They capture things in notes, and maybe they're smart enough or sophisticated enough to put it in the memics, have an internet web portal for the project, and then they decide whether they're actually going to produce it or buy it. Chances are they're just going to buy it because they really don't have the resources to produce it. They might subcontract it, for example. Okay, so system design review. If you don't know how you can develop it, you don't have a solution. Okay, really important idea. So the solution is how you intend to develop plus the target solution. And how you intend to develop is essentially the process. And if we take a look at a process, again, other course material I've developed, books, etc. A process consists of activities, iterations, artifacts, and tools. So the solution is equal to the process and target solution. They're bound together. Okay, and if you come up with a target solution, but you can't identify how you're going to build this beast, again, you just don't have a solution. Now, if we take a look at that, we could say, well, that's all very interesting. There's time associated with each of those activities, and how is that time spent? So we could view, the total time associated with developing the solution as the time associated with working with the process, and then the time associated with developing the actual solution. In other words, doing the engineering and science. And the Agile process itself, it takes time. There's no question about it, whether it's the scaled Agile or the original Agile concepts. We have our daily 15-minute scrums, and we have our bi-weekly 8-hour planning sessions as a minimum. Now, if the time for planning is greater than the time for developing the target solution, something is fatally flawed. Something is wrong. This is what the Waterfall model was accused of. People were basically saying we're spending all of our time planning and we're not out there developing the code. We should be coding rather than planning. What are we doing? Now, the reality is the setting should be such that the TP time, the planning time, is less than 1% of the total time. Engineers and scientists should be engineering and doing science is the bottom line. If they're not, then essentially you've got a skill mismatch and you're essentially not optimizing your resources. This is called overhead, and it is an efficiency indicator. We should always be efficient by definition. I mean, that's just a given. So, how is time spent? There's this idea of architecture, balance, and symmetry, and we can view this Agile process, again, whether it's the regular Agile or scaled Agile, as an architecture, right? It's an architecture that's used to help us develop the system. Now, if there is 15-minute daily scrums, where is the 15-minute daily technical exchange? If there is 8-hour sprint planning sessions every 2 weeks, where is the 8-hour team technical exchange every 2 weeks? And again, this is basic architecture analysis, and now I need to step back and say, gee, is this architecture flawed? Okay, where does Agile fit? Let's get academic here. If we were to go off and take a look at development methods, there are different folks who've categorized development methods, and they tend to fall into two categories, adaptive and predictive. And okay, maybe we can have adaptive, predictive, and very predictive. And the Agile methods tend to be associated with adaptive methods, and plan-driven methods tend to be associated with predictive methods, and formal methods are very predictive. And there's a continuum from adaptive to predictive. Again, the Agile methods are adaptive, and the plan-driven and formal methods are predictive. So, adaptive methods are about a rolling wave schedule in terms of planning. It identifies milestones, leaves flexibility in the path to reach them, allows for milestones themselves to change, and the focus is on adapting quickly to changing realities. And the adaptive team cannot describe exactly what will happen in the future. And the further away the date is, the more vague an adaptive method is about what will happen on that date. Continuing on with adaptive methods, the adaptive team cannot report exactly the tasks next week, only features they plan for maybe next month. And when asked about a release 6 months from now, the adaptive team might be able to report only a mission statement for a release, or statement of expected value versus cost. Now, a fundamental question I have, is this essentially research and development? Predictive methods, they focus on analyzing and planning the future in detail and cater to known risks, essentially. They report exactly features and tasks that are planned for the entire length of the development process. They rely on effective early phase analysis, and if the analysis goes wrong, the project must change direction. And that's lots of work to replan and, oh, by the way, update the information products. And that's why that's in red. If you don't have any information products, then voila, you don't have to deal with updating them. However, can you really survive without information products. Don't want to get too far ahead. There's a change control board. They basically ensure only the most valuable changes are considered. So let's take a look at our development methods, the settings. Okay, Agile methods, essentially low criticality kinds of environments. You have senior developers, the requirements change often, small numbers of developers, and a culture that responds to change. Plan-driven methods. There's high criticality, potentially junior developers there that need a lot of guidance. There's requirements that do not change often, large numbers of developers, and it's a culture that demands order. And the reality is change will happen. Change is always occurring, and they have to deal with it in a plan-driven method. Formal methods. There's extreme criticality. There's senior developers. It's requirements-driven. Certification is going to be needed. It's going to happen. And there's extreme levels of quality. And, life is about change, and change will happen, and they have to deal with it. Okay, so I want to go and talk a little bit about the Agile Manifesto signers. If you take a look at the folks who signed the Agile Manifesto, those with the asterisks tend to have what I will consider to be traditional engineering, science backgrounds. The other folks, they're coming from less traditional kinds of backgrounds. They tend to be marketing-oriented, business-oriented, etc. So let's just take a look at these guys. Kent Beck, he's the creator of software programming. Basically, University of Oregon is his credentials. And you can sort of go through and read his background over here. Alistair Cockburn, University of Oslo, PhD in 2003, potentially. Essentially, you see what he's been doing over here. One of the things that he did is he came up with the Cockburn scale for categorizing software projects. Howard Cunningham developed the first wiki, came from Purdue University. And then we have Steve Millar. He's probably the most accomplished. This man is obviously very brilliant. And again, very technically oriented. So essentially those are the folks that participated in the Agile Manifesto, but they are in the minority. Most of the folks there, again, are marketeers and promoters and managers, for lack of a better word. Okay, software quality. So how does Agile compare with other approaches in terms of quality? How does scaled Agile compare with other approaches in terms of quality? Now, if Agile were modified to follow, for example, the Hughes approach to engineering, would quality increase? In other words, you don't need to be dogmatic about this stuff. Just like when the original Agile approach surfaced, people were not dogmatic about it. It kept growing. The snowball kept growing. And eventually we now have scaled Agile, which many Agile purists will say, that's not Agile. What are you doing? But the point is, if we were to take the original Agile concept of doing something essentially in 2-week cycles, and rather than have a management approach to it of reporting, tasking, you took the Hughes approach to it. Would this increase quality and at the same time provide the benefits of Agile? Question. Okay, some examples. These examples are going to be coming from healthcare. This is healthcare case 1. Software was developed and presented to the hospital staff. So, this is an example dialogue that occurred. The staff. You cannot use that word on the screen because it means the patient is dead. Vendor. Just change how you view that word. Staff. No, you don't understand. That word means the patient is dead everywhere. Vendor. Ignores the comment and continues on. The doctor, who happens to be the head of the team, the one who's making a ton of money, for example, and is following a model that's a pre-World War II model, okay, a non-high technology model where all of this stuff was cooked up. He's the team head, and he basically accepts the flawed system. The reality is the system is never used, it's abandoned, it's pushed into the corner. Okay, this is healthcare case example number 1. So some observations. Could a simple paper model have found the issue early? Okay, obviously there was no paper model developed where people could provide comments. Documented evidence would have perhaps stopped payment of this flawed system because you have progress payments that you're making. And this is a crisis situation. But what is the root cause? That's very, very important. This is a crisis, but what's the root cause? Okay, healthcare case number 2. Staff using an existing system. The patient and family are stating symptoms. They assume the staff process these statements of the symptoms. As the staff is examining computer screens, they're clicking away, they're looking at all these different computer screens. There are subsequent visits and computer scans are scanned, and again the symptoms are stated by the patient and family members. So patient and family are restating the symptoms again and again. Eventually a healthcare provider arrives, and during one of these statements the healthcare provider interrupts the patient and family member with irrelevant questions. The family member clearly states that the rude interruption and states that this is a rude interruption and restates the symptoms. Obviously a stressful dialogue with the symptoms is being restated. All of a sudden the healthcare provider light bulb goes off. You could see it in their eyes. Okay, and the healthcare provider is scanning multiple screens. They're looking for something and they eventually find it. Buried on the 4th to the 5th screen down is the patient hemoglobin count. It dropped significantly. So the healthcare provider orders a test and the results are that it's even lower. A blood transfusion is started immediately. Okay, so some observations. The healthcare industry does not know the basics of human factors, let alone Mill Standard 1472. Values should be color-coded in red. There should have been an alert that the user acknowledges for certain kinds of conditions. Obviously this was one of them. For critical conditions like this one, there should have been an alarm where all the screens are locked until acknowledged. Now the question is, did they use Agile to develop this? And fundamentally they did not know what they did not know. Okay, example observations continuing on. In the early computing days, IBM concluded that it was more effective to train subject matter experts in programming than to train a programmer in a particular subject. And the reason was that a subject matter expert might take 5 years before they become expert on a particular job. An example is an air traffic controller. So what you would do is you would take one of those folks and cross-train them in programming, which would take 6 months. And so a fundamental question is, what happened? So some observations of the examples. Does it matter if managers don't know or understand what they are managing? Does it matter if programmers don't know or understand what they are coding? Does it matter if a high technology civilization has few members that understand high technology and whatever that is?